Example M6V8, a block having a mass of 0.8 kilograms is given an initial velocity of 1.2 meters to the right and collides with a spring whose mass is negligible and whose force constant is 50 newtons per meter as shown. Alright? So since there is an initial velocity, it is assumed that it will bounce into the spring, and the spring will compress until it can compress no more, and then it will begin to push the block back in the opposite direction. Okay, so we are supposed to assuming the surface to be frictionless, calculate the maximum compression of the spring after the collision, and then suppose a constant force of kinetic friction acts between the block and the surface with mu k of 0.5. If the speed of the block at the moment it collides with the spring is 1.2 meters per second, what is the maximum compression xc in the spring? So basically what we're being told from the example is that we're only concerned with these 2 points A and point C. Okay, where C is the position of the block where you have achieved maximum or maximum compression in the spring. Okay, and where A is the initial point of the block. Okay, or initial position of the block. All right. So this is basically where your block stops moving. Okay, so that the spring can fight back and push towards the left. Okay, so we in part A we identify the system to be the block and the spring, and since we are only considering two objects, we know that this is an isolated system with no non-conservative forces acting, because we are supposed to assume in part A that the surface is frictionless. Okay, so since the maximum compression of the spring is to determine, the initial position will be at point A and the final position will be at point C. We already discussed that. So considering the surface is assumed to be frictionless and applying the principle of conservation of energy, we have this expression right here. Okay, and it's pretty much just it's pretty much very procedural at this point. All right, so we already know K, we already know U in the spring or elastic potential and energy. So you just substitute the values for that here, and you will be arriving at an XF of 0.15 meters. Okay, or the maximum compression of the spring will be equal to 0.15 meters. Okay, so it's as simple as applying the conservation of energy principle. Okay, now considering in part B that there is a constant force of kinetic friction, right? Since the system did not change, we are still dealing with an isolated system. However, a non-conservative force is acting on it because a friction force is retarding the movement. Okay, so since its friction is a factor in the analysis, the normal force acting on the block has to be determined. Okay, so since it's pretty assumed at this point that that since there is no there are no forces acting on the body in the y direction, your weight will always be equal to your normal force. All right, so I don't think we have to explain this anymore. This is a very static thing. You should be done with that by now. So moving on, since the maximum compression of the spring is to be determined, it actually it's not a statics thing since you're still in probably first year. it's an equilibrium thing. So you're just dealing with the free body diagram of the block. Alright, so if you draw the free body diagram, we have the weight here, and then we have the normal force acting on the block from the surface, and nothing follows. And therefore, by summation of forces in y equals 0, weight, negative weight plus n is equal to 0, and therefore your weight is just equal to n, right? Okay, so moving on. Again, we will be analyzing point A and point C, except that we have a friction force here. So that's the only thing that changed from here to here. And you should be able to find an XF or XC or Xmax of 0.0924 meters, which is a bit lower than your Xmax if you considered it to be a frictionless surface rather. All right, so again, it's just the application of the principle. So the only way that you're gonna get this and you're gonna get it right most of the time is if you practice and get it wrong a lot of times. Okay, so sometimes engineering judgment is developed by mistakes and learning from your mistakes. So until the next module, just keep practicing.